Hi, good morning, Ananda. Today we are going to discuss our new subject WRE II, Water Resource Engineering 2, where in previous semester we had seen about WRE 1, Water Resource Engineering 1, and in same as like that WRE 1, in WRE 2 also we had 5 units itself. What are they? Well, we have a look on it. Unit 1, canal regulation works and cross drainage works based upon completely on canals. And Unit 2, stream gauging and river engineering. Unit 3, reservoir planning. How we want to plan a reservoir while going to construct a reservoir, what type of specifications we want to follow. We have to check it in Unit 3. And dams, different type of dams like earth dams, arch dams, buttress dams, like the different types of dams in Unit 3. And Unit 4, gravity dams, and specificationally it will explain about the earth dams. And in Unit 5, spillways and water power engineering. Those 5 units we are going to see in this WRE 2, Water Resource Engineering 2. We had a look on canal regulations in Unit 1, what type of canal regulators. In Unit 1, we are going to check about canal regulation works. Canal. What is meant by a canal? While going to the subject, what is meant by that canal? In canal regulation works, what type of regulations we have done and where we are going to done it? We are completely going to do that regulations in canal. A medium which transport the water from source of location to the point of need or destination, which is nothing but the water which transfer from a river to some area, which is nothing but which area which is irrigated, is called as canal. Types of canals. How many types of canals are there? Based on discharge. Based upon the discharge, we had main canal, branch canal, and major distributary canal, and minor distributary canal. Here, in the WRE1, we had seen about the canals lightly, which is nothing but based upon the discharge from the rivers, the water which discharging from the rivers, the canals had been divided 4 types: main canal, branch canal, major distributary canal, and minor distributary canal, based on boundary surface. Where those 4 types are, we had seen about the discharge, and specificationally it will come to boundary surface. What type of boundary surface we are going to use that canal? That is also type of canal: lining canal and unlining canal, which is nothing but lining canal and unlining canal, where we had seen that 4 types. And now we are going to check boundary surface, lining and unlining canals. Lining canals are nothing but the canals which had done with the concrete like PCC or RCC is called as lining canals. Unlining canals is nothing but the canals which are not done with the concrete itself, which is the mud or soil or surface, is called as unlining canals. Canal fall. Design irrigation structure construct across the canal to lower the bed level to maintain the design slope when there is a change of ground level, which is nothing but the surface of water coming from upstream side. The surface of water coming from the upstream side. There is no bed level to maintain the design slope. There is no bed level to maintain the design slope. The water coming directly from the upstream side to the downstream side. So we are going to check there and we are going to construct there a canal fall to the ground level, to the canal fall to the ground level, because of avoid surplus energy, which is nothing but when a water comes from upstream side to too fastly, then automatically water falls down very quickly to the downstream side. Then it is called as where the energy will be more. So we are going to construct the canal fall to avoid the surplus energy, which is nothing but here we are going to see the canal fall. For suppose this is the designed slope. This is the designed slope, vertical drop and available ground slope. Actually we have this available ground slope, but we have designed a canal fall from here to here, which is nothing but from this upstream side the water is coming automatically to this area. Available ground slope to this area. But we have designed this slope. We have designed this canal fall of this slope. Why? Because we have designed this slope. Especially we have designed for this slope because the low-lying areas, low-lying irrigating areas or cultivating areas doesn't take this water which coming from this upstream side. So we had done this low-lying areas this design. Automatically the water reaches the downstream side. Necessity to avoid excess earthwork. Necessity why we are going to do this canal fall to avoid the excess earthwork. Necessity of canal falls: ground surface, fall, and canal bed. Here we can easily check it out how the canal falls have been constructed. This is the ground surface, and this is the fall which we had constructed, canal fall, and this is the canal bed level. This is the canal bed level, the fall which we had constructed to water properly come from this fall and travel or discharge to the low-lying areas easily. When the slope of ground is more or less uniform and the slope is greater than the permissible bed slope of canal, to maintain the flow between the canal and drainage. Necessity and location of falls. What type of necessity we have to go into check it, and location of falls, where we have to locate the canal falls. Where full supply level FSL of channel outstrips the ground level, where full supply level of channel outstrips the ground level, where there is no loss of command area of the channel, where there is no loss of command area of the channel. Below the fall FSL is nothing but full supply level of channel remains below the ground level for 0.5 to 0.75 kilometers. Where below the fall FSL of channel remains below the ground level for 0.5 to 0.75 kilometers. Necessity of canal falls. Here we can clear picture about the canal falls. This is the upstream full supply level. This is the upstream full supply level. This is the downstream full supply level. And this is the high flood level of the canal. This is the high flood level of the, up to this the water can reach the high flood level. Where in the rainy seasons the high flood level reaches easily. And this is the fall. This is the fall of the water and reaches automatically to this canal. This is the stream. This is the upstream full supply level, downstream full supply level, and high full supply level. And this is the fall from the upstream full supply level. The water comes from this upstream full supply level and reaches to the canal automatically. When this high flood level reaches, the water reaches to the downstream full supply level. Coming water from the upstream side and reaches this high flood level, automatically water goes to the downstream full supply level. Types of canals. How many types of canals are there and what are they? We will check it once. Ogee fall, stepped fall, vertical fall, and rapid fall, straight glacis fall, trapezoidal notch fall, well or cylindrical notch fall, Montague type fall, and finally English or baffle fall. These are the different type of canals which we are going to check in, which is nothing but based upon the structure's shape or size of the structure, the canals had been divided into several types. What are they? Ogee fall, stepped fall, vertical fall, rapid fall, straight glacis fall, trapezoidal notch fall, and well or cylindrical notch fall, Montague type fall, and finally English or baffle fall. Where in this video we had checked about the canals and canal falls. In the next video we had briefly described about the types of canals. Thank you.